Good morning. Our topic is polymers reinforced with powder composites. We are Julián Espinel, Laura Rincón, Miguel Agudelo, and me, Valentina Lizarazo. Polyphenylene sulfide, also PPS, has the aromatic ring composed of 1 and 4 position sulfur atom, making relatively stable bonds. PPS has been used in many products since it has good insurance and relatively high temperatures, excellent resistance to different aggressive chemicals, and possess flame retardant and good dimensional stability. But some disadvantage of the polymer are toughness is too low and highly susceptible to crack formation, resulting in poor damage tolerance. So in this article, they included aluminum nitride, that is a mechanical hard material of high melting point and excellent thermal conductivity. These to get aluminum nitride and polyphenylene sulfide composites. They were prepared by a melt blended method. In this method, inorganic nanoparticles are dispersed into the polymer matrix, and the polymer nanocomposites are obtained by extrusion, like this. So, some tests were carried out to analyze the influence of the addition of the aluminum nitride on the crystal, thermal, and mechanical, and the electrical properties of the composites. So, in the results, the authors showed that the surface images were obtained with the SEM dose. The SEM can be used to analyze the surface morphology and structure of the microarea. So for the filler content of 5%, the aluminum nitride particles were observed to disperse randomly at the fracture zone, and the interfaces between the aluminum nitrate fillers and the PPS were presented clearly. However, it was difficult to distinguish the interfaces between the filler and the matrix when the composition was 15%. So, also the results show that the thermal conductivity of the aluminum nitrate and the PPS composites increased with the addition of the aluminum nitrate in various amounts by forming a conductive network with the composites due to the filler. So now we are going to talk about the tests that were carried out to analyze this new composite.
A straight diffraction experiment were carried out at the room temperature to investigate the effect of the aluminum nitride addition on the crystal property of the matrix. For the PPS, the most intensive diffraction peak appeared at 20 degrees. The composite displayed similar diffraction patterns to those of the NIP polymers, although wind, water, and the least estimated bits indicate the less structure order. The degree of the crystallinity was estimated from the approximate relative areas under the amorphous and crystallized bits of the diaphragmograph, as collected in a table 1. The maximum value was 74% with 50% of aluminum nitrate PPS composite. That the crystallinity of the PPS increased with the higher aluminum nitrate content and the first, and the property when the evolution content of the aluminum nitrate was over 15 volume percent, because the aluminum nitrate failure proven and the heterogeneous nucleation effect of the PPS.
I'm going to explain the TGA diagrams for PPS and AIN with PPS composites that is already shown in figure 10. So first of all, 5% loss of temperature increase from 517 to 519 degrees, as we can see on the graphic. so that we can conclude that there was an increase in the thermal stability of composites with AIM particles increasing. An explanation for that could be that the high heat capacity and thermal conductivity of AIM, which would mean that this compost absorbs in a better way the heat, resulting in PPS chains go to undergo degradation at higher temperature. Therefore, as we can see, 30% of volume in PPS improve its thermal stability, remarkable, and indicate that the field PPS as thermal material could be suitable for higher temperature applications. To conclude, the reasons for the improvement in thermal stability of field PPS were probably attributed to the increase of physical and chemical cross-linking points and the interactions between M-filler and PPS matrix.
Fine, this is the results of the tensile test. In the image, we can see that the two kinds of columns. The columns in gray are shows the fractional strength, and the columns in white shows the results for fractional modulus. And the fractional strength is the maximum pressure that the sample support, and this maximum pressure is in the y-axis and is in megapascals, and the fractional modulus is like the tendency for a material to resist bending, and is determined by the slope of a stress-strain curve produced by a fractional test. So this fractional modulus is in gigapascals in pressure, also in pressure. Fine. And with this image, we can see that the concentration of aluminum nitride has an effect on the impact strength and in the tensile test, in the mechanical properties. And these results, oh no, fine. The effects of the impact strength and fractional strength increase first, as we can see in the image, the gray columns, but when the concentrations is above 15%, decrease, and this happens because the excessive addition of aluminum nitride, but the flexural modulus increase when the concentration increase, and this says us that these results are attributed to the distribution of aluminum nitride, because could help, the authors said that could help to transfer the stress and deformate and make easy to uniform stress distribution. Okay, but what happens when you add an excess of aluminum nitride? That these could damage or make weaken some mechanical properties. Thanks.